Okay, so if we're using that Pythagorean theorem again, because we have that right triangle. So 21 squared, what was that, 441? A calculator, you're gonna need a calculator today for sure. Scientific or graphing.
441.
441 is what I recall it being. Plus a squared equals 841. Again, check my work, because.
Yeah, 841.
Okay. I've taught this a couple of times today. I do not know those by heart, I promise. So then we're solving for a squared. So what would we do with 441? Subtract it. So we get a squared to be 400. And then we do what? Square root it. So how many answers do you get when you take the square root of an equation? 2. So it's plus or minus 20. But which one do we know is really going to be the answer? Positive 20. We know we can't have a negative length of a side. So we know that this side is really positive 20. Okay with that? So now it says, okay, use the Pythagorean theorem. And remember, guys, she might not tell you to use the Pythagorean theorem. We know we're using the Pythagorean theorem, like you guys said, because it's a right triangle. Okay, but now we're going to use the values to find the 6 trig functions of b. Now, I usually circle the angle I'm talking about, or somehow note that that's the angle I'm looking at. Because if we're going to look at our 6 trig functions, we're going to start with the sine of b. What do we know sine is again? Yeah, opposite over hypotenuse. So if this is b, which side is opposite of b? What would be the length of it? Yeah, so I usually put like an O there. And which one's the hypotenuse? How do you know this is a hypotenuse and not adjacent? It's the longest side. So this would have to be adjacent, right? Now, if this was talking about A, would this still be opposite? No, this becomes adjacent, right? That other side becomes opposite. Good. So what's the sine of B? 21 over 29. Good. What's the reciprocal for sine? What's the trig function called? Cosecant. So the cosecant of B would be what? Flip that over. The reciprocal of it. Yeah, do that 29 on the top. So 29 over 21. So I would probably do cosine of B next. So cosine would be what over what? Adjacent over hypotenuse, so 20 over 29. Good. So what trig function goes with cosine? Secant. Good. So the secant of B, make sure you're putting that B next to it, would be what? Good. 29 over 20. Nice job. So sine, cosine, then we're to tangent. So tangent is opposite over adjacent. So what do we get there? 21 over 20, good. And the reciprocal of tangent would be cotangent. So that would make it 20 over 21.
That's it?
That's it. That's all it wants there. Just finding the ratios. So something really important, guys, as you work through this trig stuff is recognizing that this B, this letter, could be theta. You know, it could be in a different language. So it could be theta, alpha, beta, gamma, theta, any of those. So it could be a Greek letter or A, B, C, any of those. Those always represent angles. All of these things, these fractions, are ratios of sides. Okay, it's really important to recognize those two pieces. Because the next thing you see there is it says, what's the difference between these two things? So here you have another, it tells you it's a right triangle. It doesn't have the triangle in it. But this is a 3, 4, 5 right triangle, nice Pythagorean triple that you're going to see on the ACT. The last one was as well. But it's asking for the sine of angle B. Again, when it asks you for a trig function, it wants a ratio of sides, which is a fancy way of saying, give me a fraction. Okay, give me a decimal. Could be a decimal. We typically do fractions. So what do we know sine is the ratio of? Opposite over the hypotenuse. So which one's opposite of B? 3. And the hypotenuse is 5. Good. So what it's saying here is whenever it asks you for the sine of B, you have to make sure that you're giving the ratio of the sides. It's probably one of the most missed questions on this test later on is Whenever it says, what's the sine of B? What's the cosine of B? What's the tangent of B? Just like you did on the unit circle, okay, all you're looking for is what's that ratio, okay? But then, what if I ask you to find B? Well, what does B represent? It's an angle. So up here, I know the sine of B is 3/5, but I need to find B. Can you just divide by sine? Try that on your calculator. Try 3/5 divided by sine. It's not going to let you do it. It's going to give you a syntax error or an error of some sort. So does anybody know how to get rid of sine? Like what we have to use? Yeah. Perfect. You do the inverse of sine. So that's sine with a -1 up there. It's different than sine squared. So this just means inverse sine. So it's important. Inverse sine, inverse cosine, inverse tangent, and then you would use that ratio in the input. So on your calculator, you see that above your sine, cosine, tangent, you see that inverse sine, inverse cosine, inverse tangent. So I would encourage you to get your calculator in the right mode and just type that in to make sure you can get it typed in correctly. What mode should you be in if we're really finding an angle of a triangle? Yeah, we should be in degree mode. You want to always make sure you're in the right mode. But you would use an inverse to find the angle. So inverse sine, 3 divided by 5. I don't remember. I think it was around 36. Does that sound right? 36 what, though?
36.
Okay. And what would my label be? You're right. Degrees, right? 36 degrees. I didn't ask you for that here, but that's what we're talking about. So angle B is about 36 degrees. So remembering the difference between sine, cosine, tangent of an angle, that's a ratio. If I want the angle, you're using the inverse to find the angle. We're going to do that a little bit here. Okay there? Going too fast for you? Okay, slow me down if I am. It's nice that you have them right there in front of you. Okay, so here's how we're going to use some of that. You have this triangle there. I want you to find the measure of C. It wants us to round to the nearest whole number. So where does C show up? On the hypotenuse. So I'm going to put an H there. Can you just use the Pythagorean theorem to find C? It's a right triangle. Yeah, you don't have enough information, do you? You don't have this side, but you have this angle. So how does this side over here, how does side BC relate to my angle? Is it adjacent? It's the opposite. So what trig function are you going to use that has an opposite and a hypotenuse? Sine. So you're going to say the sine. What should come after the word sine? Okay, A. What is A? Good. So the angle needs to come after a trig function. You always put an angle after a regular trig function. Equals opposite, which is what? Over hypotenuse, which is? So how do you solve for C? You can? Yeah, exactly. So you're kind of seeing that. So if you're not seeing that, we're going to multiply by C, but you're exactly right. Yeah. Good. So you would have, I think this is like mine. It's not that. Okay, so we would have C times the sine of 25. And if you're good with that, that's 100% okay. I'm just going to show this algebra here. But yes, you're taking 16 divided by the sine of 25. Just make sure you have the correct thing in the numerator. And you were 100% correct on that. What mode should we be in? Degrees still, because we have a degree angle. So you want to make sure you're in the right mode. It does say to the nearest whole number. So what are we getting? 38. 38 what?
Degree.
Oh, is it a great degree? Look what we're finding. Oh, very good. 38 meters. Now I know Pearson you get spoiled on Pearson because they put the label. But on a test you need the label. Yeah.
So here you're not finding the angles, so are you still in degree mode?
You are in degree mode because you're given an angle in degrees. If I was given an angle in radians, I'd want to be in radian mode. So even though I'm not finding it, I want to make sure that my calculator recognizes that the angle I put in is in degrees.
Right.
Yeah. Yeah. Good question. Anything else? Trucking along, feeling good? Okay, next one. This is where you're really going to use your calculator, guys. I've taught for a while, and sometimes we miss the calculator stuff in any class, so let's not miss the calculator stuff. It's really knowing what mode we need to be in, because there are times you're going to have to go back and forth from degrees to radians, and knowing what buttons to push. And you had some of that yesterday, right, on the homework for the identities. You had to know how to type it in. So it says use a calculator to find the value of the acute angle theta. So we are finding an angle. So what buttons do we know we're going to have to push? Just regular sine, regular cosine, regular tangent? If we're finding an angle?
Inverse.
We have to use an inverse. So my suggestion, I told my students, I'm going to require that you show me some work. So if I'm finding theta, to get rid of sine, I have to use inverse sine. So Miss Mosier might not be as mean as I am. I doubt she is. But I would expect, guys, just so you remember what you're doing and how you're typing it in, to at minimum type that in right, or to write it down. Because if you type it in incorrectly, at least I have some inclination that you knew a little bit of what you were supposed to be doing. Okay, what mode should we be in? How do we know we're in degree mode? Yeah, very good. Tells you it's to the nearest degree. So that's the mode. So you just type second sine 0.8214. You're getting 55, about 55 degrees. Don't forget to put that degree symbol on there. Now guys, before we move on, what in the world does this 0.8214 mean? Like, what is it representing? Think about these triangles we're doing. What is it representing? The ratio. Good. The ratio of the sides. Isn't it true that for sine it's the opposite over the hypotenuse? It's just as a decimal. Isn't it true that you could take 2 over 3 and make it a decimal? You can take 21 over 25 and make it a decimal. That's what's happened here. Okay, so try this one at the bottom. To find theta, what button would we use now? Inverse cosine. Good. Okay, we're getting domain error, syntax error, some kind of error, right? Okay, what do you know about cosine? You know this number here is a ratio of sides. You just told me that, right? What is cosine the ratio of? Okay, what do you know has to be true about any of those as decimals? Okay, it can't be 0. It couldn't, nope, wouldn't be able to be 0. What else can it not be? It could be a radical, actually. Just good thought. Think about adjacent over hypotenuse. What do you know about the hypotenuse? It's the longest side. If you take a smaller number and divide it by a larger number, it's not going to get 1, right? Isn't it always going to be less than 1? Look at that ratio. It's bigger than 1. So that's why you're getting an error. So this would be no solution or not possible. I don't remember what it says on Pearson. I told my kids it's either no solution or not possible. But it's just impossible because there's no angle that would give you that ratio of the side. So it's important that we see that ratio. So on the next one, what's different about this one? It's in radians. Okay, so here we go. Our mode changed. Our mode changed to radians. That's the easiest way to combat that. Now we have a number bigger than 1. Is that okay? Are we going to get an error for this one?
No.
You're not getting an error, are you? Because what do you know tangent's the ratio of? Is it possible that an opposite over an adjacent might be bigger than 1? Absolutely. So now you're in radian mode, so your numbers are going to get really small. That's why it says to go to 3 decimal places. And what'd you get? Yeah, let's make sure we're getting that. Doing okay there? Questions for me? Okay, you guys are rocking this. Last thing we're going to talk about. Angle of elevation, angle of depression. The biggest thing here, guys, is we have a person, let's say in 3 places. Is this just unique to mine that it's making these nice dots? Is it usually do that?
Recording. It doesn't.
Maybe it's because I'm recording, yeah. It's funny. Okay, so if we look at this, we could be in the car, we could be here in the tower, or we could be up here in the plane. Okay, when we're talking about angle of elevation and angle of depression, there's 2 things you have to remember. It's always about the line of sight, and it's always about the horizontal. Those are the two things you got to remember. I say it to my students all the time. Line of sight, horizontal. So if I'm here in the tower, my line of sight is this diagonal, and the horizontal would be me looking just straight out the window. So my angle of elevation is right here. That's easy enough, right? If I'm also in the tower and looking at, maybe you're down here in the car, my line of sight is the diagonal. The horizontal is still me looking straight out the window. So I have an angle of depression. Depression just means I'm looking down. Elevation, I'm looking up. I'm looking up on the elevation, I'm looking down on the ground. What's different is what if I'm in the car and I'm looking up at you now in the tower, or you're in the car looking at me. This is still my line of sight. Would you agree, this diagonal? But in this triangle, is this the horizontal? What is that? That's vertical. That is not the angle I'm looking for. I'm not looking for that one. That would be wrong. So where's the horizontal? If this is my line of sight, where's my horizontal? On the ground. This is my angle of elevation. I would be looking up. Notice this angle is the same as this angle. You learn that in geometry. Alternate interior angles shows up on the ACT. Same thing happens up here. If you're in the plane and you're looking down at this person, here's your line of sight. But again, this vertical is not your horizontal. Your horizontal would be like this. So this would be your angle of depression, which is also equivalent to this if I drew a better picture. These angles are actually the same. I just did not draw it very straight. Okay, so this angle would match this angle here. You okay with that? So you just have to know where to place it on your picture. So you can look at that last example. A tower that's 125 feet tall casts a shadow 172 feet long. Find the angle of elevation of the sun to the nearest degree. Guys, where does the sun occur? Is the sun down here on the ground?
No.
No, so we're talking about the sun is somewhere up here. Would you agree? Okay, and I could even move this picture a little bit, but it's somewhere up there. Okay, so there's my sun. So what I know is I know that I have a tower that's 125 feet tall. When you go get measured for your height, do you lay on the ground? Do you stand sideways? No, so we know this is obviously 125 feet, the vertical. Where do shadows occur? On the ground. Shadows do not occur up and down. They do not occur diagonally. We would say that unless there's something impeding it, the shadow would occur on the ground. So there's 172 feet. But now I want to find the angle of elevation to the sun. Well, if I'm talking about from here to the sun, okay, am I talking about the top angle or the bottom angle? Talking about the bottom. Here's my line of sight. Here's my horizontal. I'm talking about this angle. That's theta. So how am I going to find theta? Well, I know, how does this relate to theta? It's adjacent. And the 125 is? So what do I use? Tangent. So the tangent of theta, remember an angle always goes after a trig function, is 125 over 172. So how do I find theta? Good. And what mode should I be in? Degrees, because it tells us in degrees. You were last in radians. Radians doesn't matter, guys. Your graphing calculators default to that. It doesn't matter if you're just adding and subtracting and multiplying and dividing. What it matters is when you start using these trig functions. So it says to the nearest degree, what are you getting?
36.
Okay, good. So 36 degrees. There we go. Questions on that? 20 minutes or less, a little bit